Okay, so we have a derivative of a pretty ugly looking log function here. Clearly there's a little bit of a quotient rule going on here. We have a log function and an x squared function. Prior to doing any of the derivatives, I'm going to rewrite this using natural logarithms, because I know the derivative of natural log is just 1 over x. The natural derivative of log of x to the base 7 to me isn't as clear. So I'm going to do a little change of base formula with the log of x base 7. So I'm going to rewrite my numerator as the ln of x all over the ln of 7 all over x squared, because this is just change of base where my new base is e. And again, I know the derivative of ln of x quite well. I don't really know the derivative of ln of x, a log of x base 7. So, the next thing I need to do is move this. I got a complex fraction here. I want to move this x squared up a little bit. One way I can look at it, hopefully most of you can notice that the x squared just moves up 1, but if you can't see that, I can just multiply top and bottom by 1 over x squared. These two cancel out and this x squared slides over. So I now have 1 over the ln of x squared ln of 7. Now it's a little easier for me to handle to take the derivative using the quotient rule. So, using the quotient rule, we have dy dx is equal to the derivative of ln of x is 1 over x times x squared times the ln of 7 minus the ln of x times the derivative of the denominator. Ln of 7 is just a coefficient, so really it's just going to be 2x ln of 7. The 7 doesn't really, ln of 7 doesn't really do anything. All over x squared ln of 7 squared. So x squared ln of 7 quantity squared. So these x's can cancel, so I'm left with dy dx is equal to x ln of 7 minus, I'm just going to write this 2x up front, so 2x ln of x ln of 7 all over, I'm going to make this x to the 4th and ln of 7 squared. Notice I have a common factor of x ln of 7 in the numerator, so I'm going to factor that out, and hopefully something will cancel in the denominator. So I have x ln of 7, and I get 1 minus 2 ln of x, and I get x to the 4th all over, times the ln of 7 quantity squared. So this cancels with this, I get x cubed, and one of these cancel out. So I'm left with dy dx is equal to 1 minus 2 the ln of x all over x cubed ln of 7.